we're going to take a look at sections 3.6 and 3.7. Does everybody have the guided notes from 3.6? Should say 3.6 transformations of functions. Okay, now there's all different kinds of functions. The type of function that we looked at the most in this class is just a line. Could be a line that's horizontal, vertical, or on a slant. Other kinds of functions I showed you on this calculator. Here's an example of one that looks like a U shape. Here's another one that looks kind of like a curve to it. It has kind of a curve, almost looks like that U shape, but it's only half of it, and it's on its side. Well, all these different shapes that we have, we can do what's called a transformation to them. We can take any one of those basic shapes, and we can move it. We can move it up and down. We can move it left, and we can move it right. We can also take one of those shapes and we can stretch it. Stretching kind of distorts how it looks, but we can stretch it up and down, and we can stretch left and right. So we're going to focus on mostly lines and how we can take a line and maybe move it to a different spot. I'm going to show you what you have to look for when you're doing that. So on your guided notes, the first bullet, it says a blank is a transformation that shifts a graph horizontally or vertically. That's called a translation. Some people also call that a shift. A translation or a shift takes your picture and it just pushes it somewhere else. It doesn't stretch it. It doesn't distort it. It just takes it and it moves it somewhere else. And then you have 3 blanks on the next line, and it says a translation does not change there's 3 different things. It doesn't change the size, so it doesn't make it bigger or smaller when you translate. It doesn't change the shape of it, how it looks. And it doesn't change the orientation of it. It looks exactly the same. You might be like, what do you mean by orientation of the graph? Let me show you. Let's put that one that looks like a U shape back up here. So there's a graph. Now, let me do this and watch what happens here. How would you describe the one in red compared to the one in blue? Have a guess how they would describe it? Yeah, it's like a mirror image. That's a change in the orientation of it. Right? It's not that you stretched it out or made it bigger or smaller. You took what you had and you flipped it. Okay? That's a change in the orientation. It was opening up. Now it's opening down. Okay? When you do a translation, that kind of thing doesn't happen. It doesn't change the orientation of it, the size of it, or the shape of it. So another name for translation, I think I said this already, you can also say it's a shift. Shift. So the next one, you guys already just saw an example of, is called a reflection, or sometimes people call it like a mirror image. So again, a mirror image doesn't change the size of it. It basically just takes something and flips it over. And let's just put this one up here for a second. What we can usually do is we can draw in a line that shows you exactly where it flipped. That line in green is what the blue one flipped over. Okay. Imagine you folded this right on that green line, like it was a piece of paper. The blue one would fold right on top of the red one. That line has a special name, that line in green. And that line is called, this back, a line of reflection. So on the second blank on your guided notes, It says a reflection is a transformation that flips a graph over a line called the line of reflection. So again, imagine that line of reflection like if you had paint, like wet paint on a piece of paper, okay? And you folded the piece of paper. That wet paint, when it folds over, is going to make a mirror image of what you have. And where you folded it, that's called the line of reflection. Any question on that one? So I didn't really talk about stretching or anything like that yet, but we're going to start to fill in our table now. So this table is going to be very important for everything we do all week. What I put on the board, I'm going to tell you exactly where to put it. We have, I think, 8 rows. 8 rows, yep. And we're going to fill in every box, okay, for each row. Right, so let's start with how do we do this. So under how to graph transformations, it says first, comma, and then you guys have 2 blank lines. We're going to make a table with 3 points for the original graph. So the idea is you're going to start with something, and then you're going to do something to it. Maybe it'll say, move up 2. Maybe it'll say, like, shift left 3. So we're going to start with 3 original points, and then we're going to do something to them. Let me show you kind of like an example where you might see. Let's say we had, let's take this. So let's say they gave you these 3 points. Let's say 1, 2, 3. And those are the 3 points on our original picture. So it's probably a line that looks something like this. And then the problem might say something like shift right 2. So then we'd say, okay, well this point is going to go here. This point is going to go here. And that point is going to go there. And that would be what we call the new picture. Just like the original, except everything was moved to the right too. But it's not going to say it in like an English sentence, move right to. It's going to say it in math. So we just have to know what does it look like in math when it means move right 2 or move left 3. Okay, so that's what we're going to look at. All right, so let's start with our first row. In the first row in that table, the first column says problem written like. In that first one, you're going to write number and then f of x. So you don't have to write down what I'm going to do off to the side here, but an example of that might be like this. You'll have a number in front of a formula. Okay? This formula will be given to you, but the point is there'll be a number in front of it. What a number in front does is it takes your graph and it stretches it. So under the next column where it says type of transformation, you want to put vertical stretch. So that should go in the first row, second column over. And just to show you guys an example, let's say I put a number in front of the one that I have. So I'm going to put in a 3, just making up a number. So the one in blue, that's going to be my original. Now the one in red is going to get taller and skinnier because I'm going to stretch it vertically. Okay, imagine like you had it glued down right at the origin. if you pull up on the sides of it, it would get taller and skinnier. And that's the one in red. So it was actually pulled taller. Another way you could kind of visualize it is like this. Make a copy of this. And then pull it vertically. So what happens when you pull it vertically, it gets taller and skinnier. That's what happens. So how would you graph it if you had some points to start with? What would you do to them to stretch them? This goes under the how to graph column. So this is the third one over. You're going to take your original points that you're given, and you're going to multiply the y values by a number. You're going to notice most of the time, when you have your three original points, you're only going to do something to either the x or the y. We don't usually do something to both of them. So when you stretch something vertically, it affects all the y values. Think about which axis goes up and down. That's the y. And how would you describe it? So if you want to describe what's called a vertical stretch, you write this exact sentence. Vertical stretch by factor of, and then number is whatever the number was that's in front of f of x. So if I was going to describe this one that I just wrote off to the right, first thing I would do is I would look at my table and I would say, okay, what's the one where you put a number in front? And I would go down my table and I'd say, oh yeah, number in front, that's a vertical stretch. And I would describe it by saying vertical stretch by a factor of the number in front. We'd say 3. So a lot of this is going to be looking at a formula and trying to match up which one it is in the table. I'll show you another example. Like here's another one. We haven't done this one yet. This is where you add a number onto the end. You're going to have a row in your table that tells you what to do if it says to take your function and add a number on the end. We're going to just look it up in the table once we get to it. All right, so here's our second one. Actually, this is the one I just showed you. If you have a formula and it says to add a number on the end, what that does is it moves your graph up. Let me show you, I think I already showed you guys an example, but let me show you one on here again. Okay, so there's an example of a shape. I want to move it up. Somebody give me a number for how many units to move it up. Yeah, 3. So if you want to shift something up, you add a number after the formula that you have. Okay, let's do it. There's the formula that I had, and now I'm going to add a number at the end. Okay, Darian said 3, so Dorian said we're going to add 3. So watch what happens. You can see that it went up 1, 2, 3. So adding a number on the end moves it up. Now, before I show you the next one, what do you think if you had a coordinate and you wanted to move it up? Which value do you think would change in the coordinate? If you change the x value, would that move it up? Or if you change the y value, would that move it up? You got to figure out which one is going to change. Yeah? Yeah, it's going to be the y. So if you want to shift something up, you're going to add number, whatever the number happened to be, Dorian said +3, so that in that case it would be a 3. But you're going to add whatever the number is right here to all the y values. So that should go under the how to graph column in the second row. And then how do you describe when you move something up? Well, it's pretty easy. You just say shift up. And then you say how many units. Shift up 2 units. Shift up 5 units. That would be an example of a shift up 1 unit. So if adding a number here moves it up, what do you think subtracting a number here would do? Yeah, it would move it down. Yep, and that's what we're going to look at next. So it's going to be almost the same thing we just wrote. Well, let's say instead of on the end of my formula doing a +3, let's do a -3. Here's the original. And watch what happens with the -3. It's going to be down right there. It moved it down 3. Okay, so what will a shift down look like? So under the first column, where it says problem written like, it's going to be a formula minus a number. What's the formula going to be right here? I don't know. That can be different in every problem. But the point is, it's going to be something with a minus on the end. Under the second column for type of transformation, that's called a shift down. So now same question again. If you had a coordinate, like this one, and you wanted to shift it down, which value here do you think is going to change? The x or the y? One of them stays the same, one of them changes, yeah? This is still the y. Anytime you do something that's vertical, it always affects the y's. If it's a stretch, you do something to the y's. If it's a vertical shift up, you do something to the y's. If it's a shift down, you do something to the y's. Anything vertical is a y value. And in this case, we would subtract a number from all the y values. And that would move them all down. And when I say all, you're only going to have 3. You're going to have 3 coordinates that you have to move down. And the way we describe that is we say shift down, and then you say how many units. So like if you had something like this, that's an example of shifting something down 5. All right, I'm going to put one back up there that we had earlier, just so somebody can remind me what this one was again. Let's do this. Let's put in the x. Why is it not doing what I want? There we go. Okay, so there's my original shape, and here's my new one. Does anyone remember what we called this one? Yeah? That's a reflection, right? That's a flip. Now, I want you to look at, that's the picture, and I want you to see if you can look at the original problem and look at the new one and see what I did. Does anybody see the difference between the first one and the second one? I added one thing, and this special thing causes a flip. Yeah?
It's in parentheses.
And what's in front of the parentheses?
Well, minus.
This minus. That little thing right there is what caused the graph to flip. And this particular flip is called a vertical flip, because imagine that this was like a piece of paper, fold it right on that black line, down. That's flipping it vertically, up to down. Okay, so let's go back. Right here. If you see a formula and they put a negative in front of it, a negative causes a flip. What kind of flip? It's called a vertical flip, up to down. So it's like you're folding it right up. It's like you had a piece of paper and it had an x-axis on it. You're folding your piece of paper right on the x-axis. You can call that, some people call it like a flip. You can call it a reflection. But the important thing is, how do you recognize it? It's when there's a negative in the front. So, I want to go back to my point, and I want to imagine flipping a point. And I want to see if you can tell me what would change, the x or the y. Okay. So let's say I had a point right there. If I folded it right on that green line, let's say like that was like wet paint. If I folded it on that green line, it would land right there. That's where it would land if I folded it on the green line. This would have a new coordinate. What value would change here? If this dot starts here and ends here, did the x value change? Or would the y value have changed? Yeah?
The y value.
The y value, yeah. All the transformations that I just gave you, the first four, all have to do with changing a y value. And let's actually write down what this is. It's let me move it right there so it's a little easier to see. It's right 2, up 3. Can somebody give me the coordinate after it is flipped? Yeah.
2, negative.
2, negative 3. So when it flips, there's only one thing that changed, and it was the y value. Yep.
Why doesn't the x value change because it was positive and now it's negative?
Well, the x value is how many units we went to the right. So we still went right 2 in both. If we went negative x, that would mean you go this way. But we didn't go to the left. We still went to the right in both cases. But instead of going up, when you flip it, it goes down. So all we have to do when we reflect something vertically is take the y value and make it negative. That's how you do it. So how do you graph? Take the y values and make them all the opposite. If it was already negative and you make it the opposite, it would become positive. If it was positive, it would become negative. Yep. Yep. And the way you describe this one is pretty much how it's almost the same as the type of transformation column. You just say it's a reflect over the x-axis. If you want to say vertical reflection here, you can say that. That means the same thing. So once we get this table filled out, it's pretty easy with the table. It's pretty hard to do this without the table because it's too much stuff to try to remember. Okay. So multiply y value, add a number to the y value, subtract the number from the y value, make the y value the opposite. The common theme there, y value, y value, y value, y value. Always did something to the y. Now, a coordinate has a y value, but it also has a what value? Yeah, it has an x value. So instead of talking about shifting up or shifting down, now we can talk about shifting left or shifting right. Okay? And that's going to be the next or the last part of this table. Okay? Doing something to the x's. Does everybody have that last one? Okay, let's take a look at something like this. Here's a picture. I'm going to take that picture and I'm going to go like that. How would you describe what I just did? Did I move it left or right or up or down? Aiden? So if I moved it left or right, then it would still look exactly the same. Let's go back. If I translated it left or right, I would not have changed the size or the shape of it. But this time I did change the size of it quite a bit. So yeah, that's called a horizontal stretch. And if I did something like this, that's called a horizontal compression. Stretching and that. So now we're talking about stretching left and right. So what does that look like? It's going to be similar to stretching up and down. It has to do with putting a number in front of something and you have multiplication. But this time, it's not going to be a number on the outside. It's going to be a number on inside the parentheses. So all the stuff that we did before was outside. Now we're going to do stuff inside the parentheses. And inside is what causes movement left, or it does something horizontal. That's an example of a horizontal stretch. When you put a number inside the parentheses and its multiplication. That's called a horizontal stretch. Right, let's go back to my graph and see what changes. Actually, you know what? I'll just make it again. Oh, I have it again. Here's my graph. Here's the original. This point right here got stretched all the way out to here. Originally, that point had an x and a y value, and now it got stretched way over to here. What changed about this point? Did its x value change, or did its y value change? It's only one of them. Yep. The x. As long as I do this pretty accurately, those points are at exactly the same height. So they're in a horizontal line. But the difference is one is here and the other one is much further to the right. So what's going to happen when you stretch something horizontally? The x is what's going to change. How do you do it? Well, you're going to take your three original points that you have and you're going to divide them all. Last time it was multiply. This time it's divide them all. What do you divide them by? You divide them by the number that they give you. So if this was the case where I had a 3 in front of x, I would take all of my points that I was given and divide all the x values by 3. And how do you describe it? The way you describe it is you say horizontal stretch by and you have to say 1 over the number. The reason that this divided by symbol is right here is because that's how we did it up above. So you can't just say horizontal stretch by 3 in this case. You would actually say horizontal stretch by 1 divided by 3. That's just how you say that. Okay, and that one's a little tricky, but as long as you have this chart, you don't have to memorize it. Yeah. Yeah. All right, so that's stretching left and right. What else can I do besides stretch horizontally? And we talked about this for vertically. Anybody think of something else I could do that would do something to my graph horizontally besides stretching? I want to keep the shape the same. But I could take my graph and translate it. Which way could I translate it? It would do something horizontal. Yep, or to the left. Let's start by looking at what does it look like when something moves to the left. If you go back and look at your vertical, shifting up was adding a number, but it was outside the parentheses. Shifting down was subtracting a number, but it was outside the parentheses. Well, shifting left and right is going to be adding and subtracting a number, but it's not going to be outside the parentheses. Where do you think it's going to be? Yeah, it's going to be inside. Everything we do in this part is inside the parentheses. If you add a number inside, that's going to move it left. There's an example of a graph that would move left 2 units. You don't have to write that down. I'm just showing you an example. This number can be any number. 2, 10, 6, whatever it is. The bigger the number, the more that it moves. Okay, so let's think about moving something left. What I want to figure out is what would change. Okay, so here's a coordinate. And I'm going to move it left 3. That's where I started. That's where I stopped. It went that way. What changed about the coordinate from 1 to 2? Did the x value change? Or did the y value change? Yeah? Yeah. Whenever you're moving left and right, it's the x value that changes. Let's write that down. So how do you move something to the left? Well, think about it on a number line. If something moves to the left, the numbers are getting smaller. So we have to subtract the value. That's how you move things left. And under the last column, how to describe it? Well, you pretty much describe it the way it says under type of transformation. It's a shift left. The only thing you have to do is tell me how much. Okay, if something shifted left, you can't just say shift left. You have to say shift left 2 or shift left 5. So I know this is like a ton of writing, I know, but once we do this, everything else for the rest of the week, this is like 75% of the notes for the whole week. Okay, this one thing. And you don't want to lose this, because we're going to use this sheet all week. All right, so we can shift left, we can also shift right. Does anybody have a guess what would change in this box if we move something to the right instead of the left. There's only one thing that changes. Yep.
Get rid of the plus and make it a minus.
Yep. So if you see something that's x and it's minus a number, like this, I would say, okay, there's a minus. Then I'd say, all right, the minus is inside the parentheses. That means I shift right. And we already talked about what's going to change here. It's the x value because you're moving left and right. What happens on a number line as your numbers go to the right? Well, think about, so look at this number line. What happens as you go to the right?
You get positive numbers.
And what, so how does like 4 compare to 3? Because 4 is more to the right.
You get bigger.
Gets bigger. So when we shift something to the right, all the numbers get bigger. So how do you make something bigger? You add something to it. So to shift something to the right, you add a number to the x value. In the last column, the how to describe it, it's pretty much like the column that says type of transformation. Shift right, and then just tell me how much. And then once we finish that, there's one more, and I want to see if you guys can figure out the one that's missing. We did this one. It's one of the first 4 in the table, but we haven't done it yet for horizontal. We did it for vertical. So if you look up in your table, do you see which one is missing? Yeah?
Reflection.
Yes, we didn't do the other reflection yet. What's an example of what that reflection would look like? Well, let's get rid of that, get rid of that. Let's do this and this. I'm going to graph 2 shapes for you. I'm going to show you what it looks like to reflect them horizontally. That's an example of a horizontal reflection. Again, imagine this blue one was like wet paint, and you folded it right on that black line. It would land right on the red line. All right, so look at the formula. Let's see if you guys can figure it out. The top one is the original, and the bottom one has been mirror imaged. Does anybody see a difference between the top one and the bottom one? Yeah?
Negative.
The negative, and where is the negative?
In the bar.
Yeah, it's inside. We call that a square root symbol. So it's inside the symbol. We saw what happens when you put a negative in front of the formula. That gives you what's called a vertical reflection. But when you put the negative inside the formula, like that, that gives you a horizontal reflection. It's a mirror image over the y-axis. And this is the last one. So we're done. Okay, so we want to think about what would change when you flip something horizontally. Let's actually go back to this graph right here. So let's say this point right there ends up right there. Originally it was over here, and then it ends up over here. So what changed about that red dot? Did its x value change? Or did its up and down change, its y value? Yeah.
Its x value changed.
Yeah, its x value changed. It's at the same height. It's like it went up maybe 3. But instead of going right, it went left. It went the other way when you flipped it. So how do you do that? Well, you take all your x values and you make them the opposite. If they were positive, they become negative, and if they were negative, they become positive. And the last thing is, how do you say it? Well, you say it just like under the type of transformation. This is called a reflection over the y-axis. You can also say the word flip. What I'm going to do just for the video is I'm going to put all the transformations on the screen at the same time. So if anybody needs to go back and look something up, you could pause it. And you can see all of them on the screen at the same time. They're going to be small, but on your computer you could zoom in. Okay, let's see. I think I got them all on there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Is there anything there anyone needs me to zoom in so they can copy it down? All right, so that's actually the hard part, just trying to copy all that down and get it all right. Okay, so now we've got it all. All right, so the last thing before we can do an example, you guys have 6 blanks at the bottom of your page. When we're looking at a problem, I'm going to come right back to this. But when we're looking at a problem, if there's only one thing in the problem, well, then that's easy to describe. We just say, okay, it's plus and it's a number. And we go to our chart and we look up, okay, where is plus and then a number? Oh, it's this one. It's the second one. Plus a number, that's a shift up. So in that particular problem, there's only one thing happening. But if you had a problem like this, there's 2 things happening. There's a minus a number inside the parentheses, and there's a plus a number outside. So we'd have to look up what each one of these means. What does minus inside the parentheses mean? What does plus outside mean? But when we describe them, we have to write them down in a certain order. So whenever a problem has more than one thing happening, and we're not going to do a lot of problems with more than one thing. That gets confusing. But if we do a problem with more than one thing, this is the order you always write down the 8 things we just did. Any movement left or right, any stretching left or right, any reflecting left or right. So always do the left or right stuff first. Then we write down any up and down stretching, any up and down reflecting or flipping, and the last thing would be any up and down shift. So I'm not saying we're going to do a lot of problems that have more than one thing in them, but if we do, that's the order you follow. Yeah.
Nobody's laughing.
Yep. And as long as you have the chart, honestly, I think you'll find the next part pretty easy. Okay? Don't worry about memorizing any of that. You don't have to. You can use everything you just wrote down on the test. Okay? You can use that as your reference sheet. Okay. Does everybody have these 6?
No.
And I'm also not saying if we do a problem with more than one thing in it, I'm not saying all 6 of these are going to be in the problem. There's a problem with 2. It's got a plus inside the parentheses, so we would look up what that does. And then it's got multiplying by a number in front, so we would look up what that does. That only has 2 out of the 6. Now it has 3 out of the 6. We generally won't do something with 3. We definitely will not do something with all 6 in the same column. Okay, so here's how we do an example for what we just learned. So I told you that they're going to give you a formula. Here's the formula they're giving. Okay, do you guys already have that on your guided notes? 2x minus 1? Perfect. Okay, what we want to do is first graph the original. Then something's going to happen to it. It's going to have a plus 3 on the end. So we'll look up what that does after. But first, we want to graph the original. So my suggestion is, let's pick 3 values for x. You can pick any values you want. I would pick ones that are pretty small values for x, so we can do the arithmetic easy. What would be a good small value we could pick for x to plug into that formula? Yeah? 1. Okay, we'll do it in a minute. What's another good small value? What? 2. And how about 0? You can do a negative if you want, but negatives are harder to work with, so maybe 0, 1, and 2, those are good numbers. Right. Let's plug them in and see what we get. I am not even looking at this thing that I just crossed out. Don't cross it out on your notes. I'm just saying I'm not even looking at it right now. It has nothing to do with this first part. This has to do with the new part, not the original. All right, we plug in 1. What's 2 times 1? Yeah? And then take away 1? 1. Okay, let's do it again. Let's plug in 2. Natalie, what's 2 times 2?
1.
Minus 1? There we go. Let's do one more. Emily, we're going to fill in 0. What's 2 times 0? Minus 1? Negative 1. There we go. So there are 3 points. You guys picked the x values you wanted on the original problem. Now let's graph them. Brady, how do I graph 1, 1? Can you tell me which directions? Start with your left or right. Right, how many? 1, and then right 1, up. Perfect. Anaya, how about 2, 3?
2. So go over.
Which way?
This way.
To the
Right.
to the right 2. Yep.
And then up 3.
Up 3. There we go. And Lexi, can you tell me how to graph 0, negative 1?
Go to 0. And then go down.
Down 1. There we go. So that line that I'm about to draw, I was way off. That's my original. Okay, now, this is where the new part comes in, and we're going to use the table we just did. To get the new picture, they're telling me to do this. We're taking the original, and we're doing a plus 3 on the end. So the important thing is it's plus a number on the end. We need to look that up and see what that does. So let's go back. You're looking for the one, and we can number these just so it's easy to talk about them. Plus a number on the end. which one is that? 1 through 8. Yeah? Yeah, that's number 2. Plus a number on the end says it's a vertical shift up. So let's read what it says for how to graph it. Add the number to all the y values. That's what we're doing. We're going to add the number to all the y values. Okay, so what is my number in this case? Yep, 3. And what am I going to add it to? Yeah. I'm going to add it to the y values. So the x values do not change. So let's copy those over. 1, 2, 0. Now we're going to add 3 to all the y values. So plus 3 to the y's. That's how we're going to get all these numbers. So my first one was a 1. What do I get if I plus 3 to it? Yep, becomes a 4. My second one was a 3. What do I get if I plus 3 to it? Yeah, 6. This one was a negative 1. What do I get if I plus 3 to it? Yeah, you get 2. Those are the new points. Let's graph them and see what my line looks like. 1, 4. Sophie, how do I graph 1, 4? Start at the origin and then go which way? Right 1. And then so this is my x, right? So this is 1, and it tells me to go 1 unit which way? Everybody help her out. How do we graph a point? It says to go 1 unit to the right, and then 4 units up, starting from the origin. So right 1, up 4. There's my first one. Okay, the next one, 2, 6. What does the 2 tell me to do? Yeah? Over which way?
To the right.
To the right 2, and then up 6. Right 2. 1, 2, 3, 4, 5, up 6. There's that one. And 0, 2. Maya, how do I graph 0, 2?
Start at the origin and then go up to.
Yep. Up 2. And there is your new line. Let's graph that. Not bad. I'll put that in red just so you can see it. And the black one was moved up 3 units. Took this black one and moved it up 1, 2, 3. That's where it would be. And that's it. That's what these kind of problems look like. So the first step is to graph the original and then identify using your table what to do. So look at you'll always see something like what's in your table. So this was adding outside. The next one is going to be adding inside. Okay, so now we're going to use the same formula again. The 2x minus 1. So that means you don't have to do your original coordinates all over. We're using the same problem. So let's use the same original coordinates. 1, 1, 2, 3, 0, negative 1. This time, you're adding 3 inside the parentheses. Adding inside. So let's look up what that does. Does anybody see which transformation, 1 through 8, is adding inside parentheses? Yeah, that's number 6. So everything we need to do in this problem is described for number 6. We need to subtract a number from the x values. Subtract, just remember, subtract a number from the x's. Okay, let's go back to our problem. And let's try it. So we're going to subtract. What's the number that we're going to subtract from our x values? Yeah. 3. That's the number that's right there. Subtract 3 from the x. So what's going to stay the same this time? What doesn't change for this one? Yeah. The y's. So let's copy the y's down. 1, 3, negative 1. Nothing's happening to those this time. But we're going to subtract 3 from the x's. All right, so Joe, what's my first x value?
1.
1. And what do you get if you subtract 3 from it?
2.
That'd be if you added 1 to it. Not quite, yep. Negative 2. So he was good, he said negative, but it's one more negative, so negative 2. Okay. The next one is 2. You're going to subtract 3 from it. Yep. Negative 1. And this one was 0. And you're going to subtract 3 from it. 0 minus 3 is going to give me, yep.
Negative 3.
Negative 3. So let's graph those points and see what we get. So negative 2, 1. Negative 1, 3. And negative 3, negative 1. Okay, I'm just going to do it by hand this time. There's my line. So if you compare the black and the green one, the green one moved left 1, 2, 3. It moved left 3. So well, we kind of already did it as we went, but let's describe the transformation. So for what I'll do right here is under part A. I'll describe it. And then part B. Probably would have been easier to do this as we went. Part A was adding a number on the end. So let's go back to our table. That was transformation 2. Can someone remind me, what number did we add on the end in part A? Yeah? 3. So our number is a 3. How do you describe part A? What would you write down? Yeah?
Shift up 3 units.
Yeah. You describe it exactly like it says in the quotes. Shift up 3 units. That's all you have to write. So part A is shift up 3 units. And part B, that was adding inside. Okay, I think we said that that was number 6. How would you describe part B? First, what was our number for part B? Yeah, I think, yeah, it was 3 again. So how would you describe it? Yeah. Yeah, shift left 3 units. Exactly. So shift left 3 units. Let's try. I think the rest is all just examples. So we probably won't get to them all today. We'll finish some tomorrow. But again, tomorrow is a review day and Thursday is a review day. So two review days this week. All right, let's try this. So here is your original formula. And let's just start with that. Now, for the original coordinates, you have to plug in a number for x and take half of it. Well, you can take half of anything, but there are certain numbers that come out nice when you take half of them, like even numbers. So my suggestion would be pick even numbers for x. So can somebody give me any number you want for x, preferably an even number. If you want to do an odd, we can. It's just going to come out to a 0.5. Yep. 2's good. What's another one? Yeah. 6. And one more, yeah?
4.
4? Okay. Now plug those in. Let's start with 2. What's half times 2? 1 plus 1. 2. Let's do 6. What's half of 6? 3 plus 1? 4. And let's do 4. What's half times 4? Yep. Plus 1? Good. So these are the original points. Now something's going to happen to them. Let's just figure out what the new coordinate is. This time we've got a negative in front. Just a negative in front. So let's look up what transformation that is. Negative in front. Okay, which transformation puts a negative in the front? Which number? Yep. Yep, that's number 4. That's a vertical reflection. So everything you need to do this problem is in that green box. So it says, how do you graph it? Make all the y values the opposite. So make all the y values the opposite. Okay, so let's go back to our original points. If I'm going to make all the y values the opposite, what is not going to change? The x's. So let's leave the x's alone. 2, 6, 4. And now make all the y values the opposite. So Sophie, what's the opposite of 2?
-2.
Yep. Good. -2. And then the opposite of 4 is? Yep. -4. Just making all the y values the opposite. That's what it said to do. And what's the opposite of 3? -3. There you go. So now it says to graph. It did say to graph the old one. I mean, I guess I can graph both if you want to see both. So 2, 2, 6, 4, and 4, 3. That was the original. And then the new one. Right 2, down 2. Right 6, down 4. And right 4, down 3. So you can see these 3 green dots up here got flipped to those 3 red dots down there. That's exactly what's supposed to happen. It's supposed to look like a mirror image. And then it would be something kind of like that. So the last thing is describe the transformation. Okay, so let's go back to it. Negative in front of f of x. What do you write under the how to describe it when you have a negative in front of f of x. About isn't it?
Reflect over the y-axis, so
Reflect over the y-axis would be if you had a negative inside. But we have a negative in front.
vertical reflect, so it'll be reflect over the x-axis.
Right, that's a reflect over the x-axis. The negative is in front of the f of x. And then look at it right here. The negative is in front of it. So how do you describe it? Reflect. What else could you say besides reflect? Another word you could use is, you could say flip over x-axis. So we got through the first couple. That should give you kind of an idea on the homework. What we'll do tomorrow is do the best you can on the homework. If you get stuck, don't worry. We'll finish tomorrow, and we're going to just review this all day tomorrow. So just practice this. Okay, so homework tonight, worksheet on Schoology.